Number 88. Calculate the equilibrium concentration of Cu2+ in a solution initially with 0.050 molar Cu2+ and 1.00 molar of ammonia, which is NH3. Okay, so in order to make this problem work, we needed to find a Kf value or a K value, right? Now, I knew that it was a Kf value because F stands for formation. This is our equilibrium formation constant, and it seems like we're putting these two components together. And when you put copper together with ammonia, you do form a complex ion. A complex ion just means that you have a metal with a non-metal, component, which is the NH3, and overall, they exhibit one single charge. So that's a complex ion. So maybe I'll just put that here. So the F in the Kf means that we are forming the complex ion. We need a balanced equation. And it's really cool because they did give us the two components already. So I'm just going to write my balanced equation. Cu2+ plus NH3 comes to equilibrium because we're still dealing with capital K values, and we're just going to make that complex ion. So, I mean, if you want to put the bracket here, that's fine. I'm just going to kind of say it like this. I think we're good with this. Right? Tomato, tomato. You don't need the brackets. Okay. So just know that all charges, like we've been seeing, all charged ions, they're always aqueous. And it turns out that when you are dealing with formation of complex ions, the ammonia, even though it's not charged, that's also in an aqueous solution as well. So they're all aqueous. They're all going to be included in the Kf. Now, they gave us values, right? But they did say the word initially. So that means that both of these are what we're starting with. These are your initial concentrations. And whenever we have initial concentrations, you guessed it, we need an ice table. So I'm just going to pull this out like this, right? Ice it up, ICE. And before I do that, let's just make sure that this equation is balanced. You have 4 ammonias, so just make sure that you put a 4 in front of that NH3. Maybe I'll make it stand out a little bit. And now the equation's balanced. So let's go for it. They did say that we started off with 0.050 molar of Cu2+, so that's this value. So I'm going to say initial was 0.050. And now I have 1.00 molar of NH3. Don't fall into the trap that since you have 4 of them, we're just going to take this value and times it by 4. This is for all of the NH3s in that solvent. The total molarity is 1.00. So I don't care about this for my molarity. It still stays as 1.00. We did not start off with any of the complex ion, so I'm just going to say 0. Now, for complex ions, we have a little problem. Not a problem, but this is where it gets a little tricky. But I got faith in you guys. Remember, these Kf values, they're always going to be so large. That means that at equilibrium, you should have mostly products. So that means that basically you're going to actually go through this reaction as if it was just a regular reaction, going to completion. We can assume that. But the thing is that, well, I have 2 starting values. So I need to know which one is the limiting reagent. Now, you might say that it might be the 0.05 because this is the lower number. However, it has to be on the same mole basis, right? There was only 1 mole of copper, but there's 4 moles of NH3 that's all combined into 1 molarity. So in order to find out which one we're actually going to do the math for, we have to find out which one is the limiting reagent. So what we're going to do is, since the copper is already for 1 mole, I'm just going to put that value up top here, 0.050. But now, for the NH3, that 1.00 molarity is spread out over 4 moles. So in order to find out what it would be for 1 mole, I would have to divide by the number, the coefficient number. So it'd be 1 divided by 4. And basically this is 0.050. 1 divided by 4 is 0.25, right? It's 1.00. Yep. 1.25 molarity. And now on a molarity scale, we can now see which one is the lower number. And in this case, it still is this one. But there are some times where this number might now be the smaller number. And this would be the limiting reagent. So just make sure to double check. This is your limiting reagent. I'm just going to say that this is LR, right? So what we're going to do is we're just going to assume that we're going to get rid of all of this, right? We're going to get rid of all of this to make as much as we can for the complex ion because that Kf value is so large. So I'm just going to say this is minus 0.050. But we have to do it on a mole basis. So if I say this is also going to be minus 0.050, it has to be times 4 because you have 4 to 1. So I'll times this by 4. Or you could have said minus 4 times 0.050. And now you're going to add that amount. So this would be plus 0.050. And there was only 1 here, so I don't have to multiply that by anything. Okay, so now let's actually do the math, right? Equilibrium is just bringing the initial and the change together. So this would just come down to 0. 1 minus 0.05 times 4, I get 0.8, right? For sig fig purposes, it doesn't really matter. Maybe I'll just put a 0 here. And then this would be 0.050. Now, before we go into our Kf equation, where's my variable? Right? If I have all numbers and I have a Kf that's a number, what am I solving for? Well, that's the assumption. We don't really have nothing left, but we have basically a number that is very, 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 very close to 0 that we're basically going to say that this is x, right? If this number is so small, it's basically so close to 0 that this is the x value. All the other numbers, since they are predominating, we're just going to assume that that is going to be the predominant molarity. And now we have an x value. And now let's solve. So I'm going to take all of this because I want to just kind of make everything together. We're going to pull this over here. And now let's do the math. So we have Kf equals concentration of products divided by reactants. So I have one product. So that's the Cu NH3 4 2 plus divided by the 2 reactants. And we have the Cu 2 plus and then the NH3. Keep in mind that because you have a 4 in front of the NH3, this concentration has to be raised to the 4th. And now let's just plug in our numbers. Kf is going to be 1.7 times 10 to the 13th. This is going to be 0.05. The copper is going to be the x value, and the NH3 is going to be the 0.8. Okay, so let's go for it. 1.7 times 10 to the 13th equals, let's see, I have the 0.050 on the top, and then we have x times 0.80, and that's raised to the 4th. We can basically combine this, right? 0.8 to the 4th is 0.4. So I'm just going to erase this. We're simplifying now. This is basically times 0.4096. So what I can do is just cross multiply, right? So I'll take this value on top and multiply it by the number on the bottom. Okay, we're getting close. So this is going to equal the 0.050. And then I have that number times 1.7 times 10 to the 13th. So I get 6.9632 times 10 to the 12th. and that's times by x. So just move this over a little bit, times by x. We want to solve for x, so we just have to divide by that number on both sides. 6.9632 times 10 to the 12th. 6.9632 times 10 to the 12th. This will cancel. And now we're just left with the next value. 0.05 divided by that number. And looks like 2 sig figs. So 7.2 times 10 to the negative 15th. I mean, really, really, really small. Do you see how this value is so close to 0? That's where you assume. Now we just have to answer the question, right? Let's just go back. Let's see, who are we actually solving for? We want that equilibrium concentration of the Cu2 plus. And the Cu2 plus was the x value. So if the Cu2 plus was just x, and x was 7.2 times 10 to the negative 15th molarity, that's the end, right? These answers are in molarity. So that's the end. Woo. So don't let that trick you guys. If we're doing complex ions and you have 2 initials, go back to just a regular stoichiometry limiting reagent problem. All right, just find the one that has the lowest number of moles and then go from there. All right. So I really hope this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel if you want to help us out. We're almost at 20,000 subscribers. So thank you so much for that. I really can't believe this channel has gotten, as much, viewings as it has. But I'm really glad that we can help you guys in your education journey. So thank you. I will talk to you soon. Okay, bye-bye.